Assalamu alaikum, Bismillahirrahmanirrahim. After long days, we'll resume JNCIS-SP, that means Service Provider Specialist Force. We're in MPLS section in JNCIS-SP. As per last class, we're in module 4, that is MPLS static LSP and the forwarding plan. So as this is the after long days, I take this class. So first, we start this module from beginning. So there is a static LSP and forwarding plan. So this is our topology to check our MPLS. So first, to go to the slide, MPLS fundamentals. So this is basically 5 section, maybe, yes, 5 section. We'll discuss theoretical concept and the configuration both. So let's start configuring your networks to host the MPLS service. So first, you have to configure your device to preparing MPLS services. Okay, so this is some terminology and acronym. So which is used in MPLS. We will um, discuss one by one in MPLS journey. So let's start. Putting the theory into practice, that is, here we can see when you configure the MPLS, you will get 2 tables. Number one table is INET.3 and another table is MPLS.3. So INET.3 is the basically core MPLS routing table, and the MPLS.0 is its forwarding table. Okay, so this is the sample topology for testing MPLS. Both all router is in same AS, and they are asking for desktop. You know, when you configure the BGP, especially in IBGP, desktop is very important. IBGP don't change desktop itself, but EBGP can do. So if you want to change desktop, you need a policy. So it's just this scenario. So first, enabling core interfaces for MPLS. First, you need to enable MPLS in your core interfaces. So for MPLS, you need to complete 2 steps. Number one step is family MPLS in enable family MPLS in core interfaces, and another one is protocol MPLS. Add core interfaces in protocol MPLS. So this 2 step to enable MPLS. This is the basic and very simple configuration. So let's check. We are already configured our device or not. So let's go to our topology. It's our topology. This is PMX1, and there is basically 10 router here. So the core interface will be for PMX1. The core interface will be this interface and this interface. Customer can connect with PMX1, but this is not the core interface. This is a customer interface. PMX1 can connect with the upstream. This is not the core interface. This is upstream interface. Core interface means it's a MPLS backbone. Means MPLS backbone. So let's start. So for VMX1, the core interface is C0 by 0 and C0 by 1. So let's check our core interface MPLS is enable or not. So C0 by 0 family MPLS, 0 by 1 family MPLS. So family MPLS is configured already. Under MPLS, core interface is added here. So this is the two step. Number one is enable family MPLS, and number two is adding core interfaces under protocol MPLS. So similarly, checking the configuration from different router and getting set. Or you can say, you can mass here MPLS, yeah, or two interface is code. For VMX2, the core interface is 3, 0, 1, 2, 0, 1, 2, 0, 1, 2. It's okay. For VMX3, 1, 2, 3, 1, 2, 3. For VMX4, 2, 3, 4. VMX4, 2, 3, and 4. For VMX5, interface is 3 and 5. VMX6, the interface is 0 and 1. 7, the interface is 0, 1, 2. 8, interface is 1, 2, 3. 9, the interface is 2, 3, 4. 2, 3, 4. And the last one, 10. Interface is 3 and 5. So MPLS is already enabled in our topological routers. So let's go to our slide. So our first step is done, and second step is verification. Second step is verification. So how to verify? The command is show MPLS interface, and you can check in your topology here. Branch PLS press to interface is enable 0 and 1. 1, 2, 3, 0, 1, 2, 3, KMX4, 2, 3, 4, KMX5, 3, 5, KMX6, 0, 1, 0, 1, 2, 8, 1, 2, 3, 9, 2, 3, 4, and last one is 10, 3, 5. Okay. Our verification has done. Then go to next slide. See here. If you want to configure a static LSP, LSP means level sys path. So here you can set label manually or statically. Okay, but in production, APLS label will distribute through protocol. You can use LDP, you can use RSPP, or you can use segment router. Okay, so this is the concept. When you want to configure a static LSP, you can use the static LSP labels. The label value is this is the starting value for static assignment. For a static assignment, you can start from here, and this is startup, and this is the end. So labels, this value, starting value, this is the ending value, are reserved for static LSP. So you need to remember this one when you configure the static LSP. Okay, so after 1, the 0, 3, 0, and the 3, 0, 6. So after 1, 6. Okay, so see here, this is the router 1. You can say it's a ingress router. So in router 1, sending the LSP or sending the label towards router 2, the label is 1001212. It's the static label. From router 2 sending label to router 3, router receiving one label which is coming from router 2 and swapping the label towards router 4. So you can say router 2, 3, and 4, it's the transit router. And this one is the last one router. This is called the egress router. So from last to second router, it's a PSP router. That means penultimate hop topic. They are removing the label and sending the normal packet to last in router, that is egress router. After this router, you can connect your customer device. Okay, customer can take different services from MPLS background like L3 VPN, like L2 VPN. Okay. Okay. So it's a just check your understanding. Voice command can be used to verify the MPLS enable interface. It's very simple. Show MPLS interface. This is the command for verify MPLS is enable in your core interfaces or not. And the question 2, what is the configuration involved in enabling core interfaces for MPLS? By adding the interfaces under protocol MPLS. And another one is you have to enable family MPLS in core interfaces. These are the main two steps to enable core interfaces for enabling MPLS. And this is second section, static LSP configuration and verification. So let's start verifying the head-in router. So here you can say the router, if you start from left, you can say it's a head-in router and this is a tail-in router. You can say it's a ingress router and this is the egress router. This is just naming terminology, or this the you can say it's an MPLS terminology or acronym. Okay, so let's move for configuring a static LSP. How to configure the static LSP? Just from head-in router, that means your head-in router is, or you can say the ingress router. Your ingress router is router 1, it's the router 1, and they are just push or insert label towards router 2. So your static LSP will be and set protocol MPLS. This is the name. Static label, so is path, and this is the user defined name. Router 1 to router 5. Ingress, this is the ingress router. Next up is router 1 and router 2 interface IP address. And this is the final destination. And the 1.5 is loopback of router 5. And the operation is push or insert. And setting the MPLS level. So how to configure static label in ingress router? So consider in our topology, it's a ingress router and this is the egress router. So I'm configuring static LSP in PMX1. So let's start. How to configure static our sample level value is 100, 1 to 1 2. Okay. So first you need to go under MPLS protocol. Okay. Then set static 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 levels is path, and you have to set the name here. And the name will be user defined, but should be mini. So here I will set the name PMX1 to PMX 5. After that, my router is ingress router as per my topology. This is the ingress router. Okay. Then uh, need to define next hop, and my next hop will be router 2. So router 2 interface C 0 by 0 interface IP address C 0 by 0 interface IP address is this one 10.1.2.2. So this is my next hop, and to set the destination address of egress router. So my egress router loopback IP address is show set fast 0. Loopback IP address is this one 1.5. So this is my egress router loopback IP address. I'm setting here, it's a ingress router, the next hop, and the target. And last one is insert the label. Start the level. The level value is starting from 0, and this is the ending value. But you have to configure this range because you are configuring statically. Okay, you are configuring statically. The range should be this one and this one for statically. So go here and set the example level value is 100, 1 to 1. So set similar 1 to 2. That's perfect and show. So it's a static LSP. Your static LSP configuration done. And go and check. Yes, your configuration is okay. Then cut. So this is the way for configuring static LSP. So next one. Ingress verification checking the LSP status. So after configure, you can check the static LSP status. Show MPLS static LSP ingress. Show MPLS static LSP ingress detail. Two verification command, and is the another command for checking the route and BGP next up resolution in the island.3 table. It's the different. So first, show MPLS static LSP ingress. Run show MPLS static LSP, and the type is ingress. Yes, and this is the name of static LSP and your LSP is up. Stat is up. Okay. Displayed one and up one. No down. So you can say detail and the state is up. This is the next up and this is the outgoing label and the label operation is push and when it is grading. Okay. So this is the static LSP verification. Next, route. I have to check my route table. This is my final destination, 1.5, and show route. And checking here, this INET.3. INET.3 in under INET.3, I'm getting this route, MPLS, and the next one. And this is the manual level value or static level. So need to recheck you INET.3 and INET.0. Both you will get this route in both breakdown. So for this, you have to check OSPF status. OSPF is okay or not okay. Run show OSPF neighbor. No OSPF is running here. This is the region. This is the region not getting INET.0. Okay, not getting the INET.0. So let's configure OSPF. No OSPF configuration is there. So set protocols, OSPF, area, 0, interface, hello 0, dot 0, or yes. Every router, the configuration is same. Configuration is same. Second, for router 1, 0 and 1, interface GE, G0 by 0, interface type into P, 0 and 1. So, what's the configuration done for IPv4 in BMX1? For BMX2, 012, or BMX2, 012, 0, two. BMX3, 1, 2, 3. Two, three. Three. BMX4. 4 is 2, 3, 4. 2, 3, 4. Router 5 is 3 and 5. Three and 5. Router 6 is 0, 1. Router 6 is 1, 0. 0, 1. Router 7. Router 7 is 0, 1, 2. Zero, 2. Router 8. Router 8 is 1, 2, 3. Router 9 is 2, 3, 4. Last one, router 10. Router 10 is 3 and 5. So what's step done? So let's do what we have. Yes, first step is up. It's good. 3 number. Here is 4 number. 1, 2, 3. 1, 2, 3. Okay, not 4. Please mute. Please mute. For 8, yes. So or IPv4 unicast start, that is LSPs. Now check route again. Now we'll get two route table. Now we'll get two route table. Number one is inet.0, that is coming from OSPF routing protocol, and another is inet.3, that is basically MPLS routing table, that is coming for basically static LSP. Okay, we statically define the LSP. Okay. So let's move. Our static LSP in ingress router configuration done. Also, we verify the LSP. Okay, so say BGP next of resolution in the inet.3 table. It's basically same concept which is discussed in BGP. BGP not resolve the next of basically in iBGP. So need a policy to resolve the or changes the next of. Okay, so for BGP you can consider this topology like this. One customer is connected here. Customer is connected through eBGP. Customer sending 1/24 prefix in router 5. I'm just checking this prefix from BMX1, which is coming from BMX5. So if you want to resolve the next stop, need policy, next stop policy. Okay, we already know this. Can move. Why is this inet.3 only used in BC? network 3 only use BGP, not using another ICP like ISS or WSP. Only coordinate with BGP. The reason is, remember the primary use cases for MPLS. We use MPLS for traffic engineering, BGP free for, you can use this one. MPLS VPN, L2 VPN or L3 VPN. That is rarely used for WSP or ISS prefixes to use an LSP. Nothing important. So the BGP use this. Okay. Which commands are used to verify? These are understand, check your understanding section. That is basically question and answer section. Which commands are used to verify the status of an LSP and the egress router in static LSP configuration? We already checking this one. After configuring the ingress static LSP, we have to verify the command is show MPLS static LSP ingress. Another command is show MPLS static LSP ingress detail, and another one is route. Run show route and set the target IP. And you will get the two route table. One is network 0, another is the network 3. Basically, network 3 is the MPLS route. We travel to Junos look into the resolve PGP next stops. That is network 3 and network 0. BGP basically use both travel network 0 and network 3. And only BGP can communicate with network 3. Other protocol like ISS OSP can't communicate with network 3. So this another section, same the static LSP configuration, but your router will be the transit router. Your router will be the transit router. For transit router, you will get incoming level and set outgoing level and send to next time. This is called the transit. It's called the transit. The example configuration of transit router, say here, this one is the incoming level and this is the outgoing level. The operation is swap. Operation is swap. And the router role is transit. Router role is transit. So let's configure static LSP for transit router. And this is the verification. Verification command is same. Also, you can check MPLS route table. Also, is specific. Is also the transit. So execute this one first. Okay. So let's see. In our topology, VMX2 is the transit because VMX1 in starting level, sending level to VMX2. VMX2 are receiving incoming level which is coming from VMX1 and sending another level towards VMX3. So that's why VMX2 is the transit router. And the operation will be swap. So how to set edit protocol MPLS. Under MPLS protocol, set is static levels is path, and now I'm in BMX1. Oh, this is the wrong router here. Need to configure BMX2 protocol MPLS. Set is static levels is path. You can set your name. See here, name is router 1 to router 5. Same name. We can use same name, PMX1 to PMX5. The operation or role is transit and set the incoming level. set the incoming level. After transit, set the incoming level. So in our BMX1, the level we push, this level push. So we will receive this level as incoming level in BMX2, and outgoing level 2323. Okay. So outgoing level, your operation will be swap, and outgoing level 100, sorry, 2323. Okay. This is router role. This is operation swap. This is the incoming level and this is the outgoing. Okay. Then need to set next. Need to set next. So the next hop, my next hop will be BMX3 interface is 0 by 0 by 1. Show mass 0 by 0 by 1. Next hop IP address is this one, 10 to 3.3. So set the next hop, enter, and save. Static LSP configuration, and the router is transit router. The operation is swap. I mean the configuration, your configuration is okay, and check run show MPLS static LSP, and my router is transit. Static LSP transit. Status, yes. Status up, and you can say detail here. This is the incoming level, and the outgoing level, this is the outgoing level, and the level operation is swap. This is the next hop and outgoing interface. So this is the verification. Verification. This is the verification. Level operation is swap, coming and outgoing level. And you can also check MPLS table. You can also check route table. Okay. So let's move to our topology. Run show MPLS. Sorry, run show route table, and the table is MPLS.0. See here, this is the incoming level and this is the outgoing level. The operation is swap, and this is coming from static LSP. Coming from static LSP. Okay, so that's good. And then move to BMX3. BMX3 also receive incoming level from BMX2 and sending another level to BMX4. This operation also transit. BMX3, if you configure static LSP in BMX3, operation will be transit. Okay. So BMX3 for BMX3. 2 3 for BMX3, move to BMX3, static protocol, ALS, set static level switch path name is BMX1 to 5. Operation is transit. Need incoming level. So which one be the incoming level? This one will be the incoming level for BMX3. The operation same, the swap, and the outgoing level is 100. 3, 4, 3 to 4. That is 3, 4, 3. Need to mention the next hop, and my next hop will be router 4 uh, C0 by 0 by 2 interface the IP address. So mass business. So my IP address is 10.3.44. I'll set the next one. So for router 3, my static LSP configuration done. Similarly, you can check and show route table MPLS.0. You will get this one. This is the incoming level and this is the outgoing level. Also, you can check MPLS LSP, MPLS static LSP transit. Status is up. You can say a detail. This is level operation is swap. The outgoing level is 3. Okay. Now moving to BMX4. BMX4, this router is the PHP router, an ultimate hopping router. Okay, edit protocol MPLS. This router basically pop the level. That means remove the level. Okay. See here, the role is transit and the operation is pop. This router 4, removing the label and sending packet to last router, that is egress router. Okay. So pop means removing label. How to configure? I'm just receiving the incoming level and pop not setting the outgoing level. Set the next. So and the role will be transit. Set static levels is path. The name. What will be the name? Name will be BMX1 to 5. BMX1 to 5. The router is transit. Okay. Um, router is transit. Need to set the incoming level. So what will be the incoming level? What will be the incoming level for VMX4? Anyone? This one will be the incoming level for VMX4. Incoming level. Your operation is pop. Removing the level and set the next. Set the next. The next stop will be router 4 to 5. 4 to 5. That means router 5, 0 by 3, interface 3. Minus 3. IP is this one. So set this next up. Okay. Your configuration is done. In MPLS backbone, ingress router operation is push. Ingress router operation is push. Transit router operation is swap. Transit router operation is swap. So route table ls.c pop and this PHP router DMX4. This operation is pop, removing the incoming level which is coming from DMX3, assigning implicit level to DMX5. Okay. And So it's a verification from router 4, MPLS route table. The operation is off, and this is the incoming label. Here S means the bottom of the stack bit is not set. Okay. So verifying end-to-end connectivity. When you sending packet from site 1 to another site, which is connected with router 1 and router 5. So this is the sample snap. So let's connect site A and site B with router 1 and router 5, and then check the connectivity. Okay, so let's move our topology. Now shutting down up. So now we are in page 31. So I think this is big. So let's close for today. We will start next session for page 31. So up to this, is there any question? You can ask. Is there any question? Okay. So Allah Hafiz.